Last class, we talked about where the ammeter goes in an actual circuit in order to read current intensity. Okay, and we talked about how current intensity was the amount of charge going through one point of an actual circuit at every second, so at any one time. Okay, and we talked about the fact that the ammeter is always going to be in the actual loop. I call that in the circle of friends, okay? So it's part of the actual club. Now, so what ends up happening here is that the wire goes into the black. Black is the beginning, and it goes out the red, okay? So it will actually, this wire will actually go from here into the black and out the red as being part of the circuit. Okay? So now, anytime, and we're going to start, our first lab is going to deal with something called a simple circuit. A simple circuit is something that only has one object in it that's going to do something. One resistor. And the resistor we're going to use is going to be a what? Yeah, light bulb. Light bulbs are nice and easy. I kind of like them because you know right away if it's working or not. If the circuit is properly hooked up, what should the light bulb do? It should blink on. Absolutely. So here's my symbol for the light bulb. There we go. I now have a simple circuit and I'm measuring current intensity. Okay, it's going to give me a little reading, right? Now, here's the deal. The next thing we're going to be talking about today is something called potential difference. When we talk about potential difference is also known as voltage because the unit of potential difference is the volt. When we talk about potential difference is actually the amount of energy that is transferred between any 2 points in an electrical circuit. So I know that some of you are sitting there going, what does that mean? When we actually look at the equation for power, for the potential difference, we see that it actually does mean what the actual what the actual formula or what the actual definition of potential difference is. And the formula, okay, is V. Here, V is going to be equal to big E over Q. Now, one of these units you've already seen before. Which one? Q. You've already seen Q. Does anybody remember what Q stands for?
The time.
No, the charge. Close though. Right formula. So Q stands for the charge. And we know that the charge is measured in coulombs, right? So what this is saying, that when we actually measure the charge, if you remember, the whole idea of current intensity is the actual charge going through a point at any one point in a circuit every second. So it has everything to do with a specific point in an actual circuit. So here, the voltage or the potential difference of a circuit has everything to do with the amount of energy going through at one point in time in a circuit. Now that is measured by something called a voltmeter. So we remember we had a box with a little A in it, the red ammeter, and we're going to have a darker, it's either black or blue, dark blue, box that reads the voltage. Okay, and here's the big difference between the two. What is anything in, there are two things in this circuit here, okay? I'm going to actually move my circuit down. There are two things in this circuit that actually emit or use energy. What are they? Okay, what's the one thing that emits energy in this circuit? The power supply is going to emit energy. Okay? So here I've got my power supply. Now, what is going to take energy and use it to make something in this circuit? The light bulb or the resistor. When the actual resistor is on, okay, when the circuit is flicked on, this light bulb will light up. Okay, so here's the deal. The whole point of potential difference here is to measure how much voltage, okay, or how much potential difference each object in a circuit uses. Now, this is a simple circuit. So if I set my voltage, okay, if I actually set my voltage to be 10 volts, and we saw that on the power supply, that just means turning the knob to 10. It should emit 10 volts of energy, right? Should emit that amount of energy. And we saw that when the actual energy or the voltage was lower, every time I clicked it a little bit higher on the knob, the light got brighter and brighter. So the more voltage going through a circuit, the more energy there is, the more energy will be actually used up by the light bulb, the brighter it shines, right? And you saw that when I lowered it, the light bulb was still on, but it dimmed, okay? So here's the deal. When you have a voltmeter, the voltmeter is never part of the actual circuit loop. It is always on the outside looking in. Okay, it is not part of the circle of friends, let's say. All right, so one of the first things you have to do in an actual circuit is you always must test your power supply. Because even though it says that you've got it set at 9 volts or 10 volts, how do you know that it's actually working? You have to actually get a reading on the power supply. And what you would do in this case is the power supply would actually be, and I'm just going to erase this just a wee bit here, and I'm going to draw in that box for our power supply, right? And we know that the power supply has a black knob and it has a red knob. And it also has a little dial here to tell you what the power's at, okay? When you want to take the reading of the voltage of the power supply, the voltmeter, and we're going to draw it in black, sits on the outside of the circuit. And it's a little box with a V in it. That's its symbol. The voltmeter also has a red knob and it also has a black knob. Okay, so in this case, we'll use a different color for my wiring here. Okay, this actual black one would be attached to this one, and this black one, this red one would be attached to this red one. You turn it on, you will get a reading on your voltmeter. And it should equate, it should be the exact same reading that your circuit is set up to. Okay? Now, what's actually happening here is by plugging it into the power supply, you're taking a reading of the amount of energy that is passing through the power supply at any one moment. Okay? It's reading what goes into the power supply and what goes out of the power supply. All right, so that's one measurement that you make. Now, I am going to undo all of this, and I'm going to go back to my vintage circuit. I'll get to your questions in a minute. If I want to actually read the amount of power, or I'm using the wrong word, the voltage or the potential difference going through the light bulb, okay? I'm going to set up my voltmeter so that it basically surrounds my actual light bulb. And here's the deal. Just like the ammeter, this is going to have a black knob and a red knob. The black knob always goes and gets attached to the beginning of the light bulb. The red knob gets attached to the end of the light bulb. And what's going to happen here when I turn the power on, okay, when the energy starts flowing through this actual circuit, it's going to sit there and it's going to go out this wire. It's going to come down here. It's going to go into the ammeter. The ammeter is going to read it. It's going to come out of the ammeter and it's going to continue on here and it's going to go into the voltmeter and it's going to come as the energy is actually going through here, okay? And it's going to come out and give a reading. And then it's just going to go on its merry way to finish the loop back at the power supply. So the voltmeter is always on the outside of the actual circuit diagram. And it's always drawn basically, and I'm actually even going to take off these wires and these little lines. We actually, when we're drawing a circuit diagram, we actually show a line going in and a line coming out. So that it's actually taking a reading right here. It's when it starts, right here when it ends. And the amount of energy going through that, that'll pop up as potential difference on your voltmeter. You are going to do a simple circuit lab that's going to explain to you how to do this step by step. Okay? But notice how the voltmeter is never actually part of that green loop. The ammeter is part of the loop. Okay? If I was to actually pull all the ingredients and all the objects out onto and kind of make a loop here, I would see that the voltmeter almost looks like this added. It makes it look kind of like a box with a wire going to your ammeter, and then another wire going to your light bulb, and then another wire going back to your box. And this looks like a wire going to your voltmeter and a wire going here. It almost looks like an 8. Okay, where you've got an upside down 8, where you've got the little loop here and the bigger loop here. Do you see that? The voltmeter is never part of the actual circuit loop. If you put it in the loop, it's not going to work. Okay, you will not actually get a reading. And that's one way to know whether you're doing it right or not. Just like if you actually flip-flop here and you swap the ammeter to be outside and the voltmeter to be in, neither will work. So that's a good kind of indicator. If the little line on the reader doesn't move anywhere, then it's not, you've done something wrong.